Okay, let's take a look at the stoichiometry in-class activity that you have due on Tuesday. And you can see which one that it is. This is the one that's due. So if you weren't in class today, now you know what's due on Tuesday. I'm going to go ahead and get you started off. So given the following equation, this is the Haber-Bosch reaction for making ammonia. Here are the possible equality statements. And essentially, these are just mole-to-mole relationships, guys. That's all these statements are. This is just saying that 1 mole of nitrogen is equal to 2 moles of ammonia, 3 moles of hydrogen equal to 2 moles of ammonia, and 1 mole of nitrogen equal to 3 moles of hydrogen. And it's expressed it in two different ways for each relationship. And all they did was they just inverted it from one to another depending on what it is that you're looking for. So 1 mole of nitrogen over 3 moles of hydrogen, or 3 moles of hydrogen over 1 mole of nitrogen. And it did it for all three components. So now we have this particular reaction, and we're going to do the same thing. We'll just say, let's say 4 moles of iron over 3 moles of oxygen, or alternatively 3 moles of oxygen over 4 moles of iron. And then we'll just continue on. We can do 4 moles of iron, Fe, over 2 moles of iron 3 oxide, which is just rust, Fe2O3, or just reverse it, 2 moles of Fe2O3 over 4 moles of iron. And then last but not least, you've got 3 moles of oxygen over 2 moles of Fe2O3, or just reverse it, 2 moles of Fe2O3 over 3 moles of O2. And those are all the possible relationships for mole-to-mole ratio. So it's quite a few, and whichever one is on top, which determines which one you're going to eventually calculate. Whatever's on bottom is a division. That's usually what you're trying to get rid of, and you're going to what's in the numerator. Okay, so let's dispense with that. Let's go ahead and move on. So here we go, and we're just going to use the mole-to-mole ratios. The how many moles of H2, that's going to be this value right here, what I'm looking for, H2 equals. And so whatever is the how many part, I strongly recommend that you do that you put X moles or X grams or whatever you're looking for over here, then an equal sign, and then you go find the other stuff. Okay, and so this will be 34.8 moles of NH3. And we're just going to use those mole-to-mole ratio or relationships or equalities that we talked about before. And we are relating moles of H2 to moles of ammonia. We want moles of ammonia to go away, so they go down here in the numerator. Anything you want to go away goes in the denominator, my bad. And then we have 3 moles of H2 in the numerator. When I multiply and divide across, remember, you're multiplying in the numerator, you're dividing by the denominator. So that's just going to be 34.8 times 3 divided by 2, which gives you 52.2 moles of H2. And that would be my answer. So that's how many moles of H2 are needed to produce 34.8 moles of NH3. Let's go ahead, scroll down, see what we got. Okay, here's another example. You have some problems in between. And here's the other example for part 3. Again, Haber-Bosch, how many grams of nitrogen gas are required to react with 4.27 moles of hydrogen gas? So here we go, the how many grams part, that's our X, and so that's X grams of N2 equal sign, and then we go get the other stuff, which is 4.27 moles of hydrogen gas. So our relationship now is going to be between hydrogen and nitrogen. I've got hydrogen gas. I'm going to want it to go away. So in my conversion factor, or my mole to mole ratio, this is going to be 3 moles of H2 in the denominator and 1 mole of N2 in the numerator. Now that takes me from moles of H2 to moles of N2. But keep in mind, I'm not looking for moles of N2, I'm looking for grams of N2. So, sorry about that last little blurb right there. That was a little bit of a mess. Let's clean that up, and here we go. So this is going to be 1 mole of N2, and the molar mass of N2 is 28.02 grams per 1 mole. So moles of N2 will cancel. That's going to give me grams of N2. And so I go 4.27 times 1 divided by 3 times 28.02, which gives me, it looks like 39.9 to 3 sig figs. 39.9 grams of N2. Okay, so that is a moles to grams calculation. Let's scroll on down, and this is all for you. You can go ahead and fill all of that out. Here's another one, another example, same reaction. How many grams of ammonia? Okay, so from 11.2 grams of hydrogen gas. So this is officially a gram to gram stoichiometry problem. See if I can spell that without messing it up. I think that's it. All right, and it has 3 parts, guys. You need to go from grams to moles, mole to mole ratio, from the balanced chemical equation, and then moles to grams. And they all work the same way when you're doing gram to gram stoichiometry. So here's my how many part. That's X grams of NH3. That's what I want to wind up with. And then the other stuff that goes on the other side of the equal sign are the 11.2 grams of hydrogen, H2 gas. So we're going to do grams to moles. How do we do that? We divide by the molar mass. Then we're going to do mole to mole, which we get from the coefficients of the balanced chemical reaction. And then moles to grams, we're going to multiply by the molar mass. So this is hydrogen. Each hydrogen is 1.01, so that's 2.02 grams for every 1 mole of H2. And then the mole to mole ratio, I go up here and I say, 3 moles of H2, and that takes us H2, and then 2 moles of ammonia. 2 moles of ammonia. We want to wind up with grams of ammonia, so in the mole to mole ratio, the moles of ammonia coefficient goes in the numerator, not the denominator. We're trying to get rid of or get out of moles of hydrogen. And finally, 1 mole of NH3 ammonia weighs 17.04 grams. All right. 1 mole of nitrogen, 14.01 plus 3.03 for the 3 hydrogens. So grams of hydrogen cancel. Moles of hydrogen cancel. Moles of ammonia cancel. And we get our answer, which is going to be, let's do it, that's going to be 11.2 divided by 2.02 times 2 divided by 3 times 17.04. And that gives me 62.986. Let's see, how many sig figs? 3. I'm going to call that 63.0 grams of NH3. And that would be my answer for that part. Okay, so remember, when you're doing gram-to-gram stoichiometry, grams to moles, divide by the molar mass. Mole to mole, coefficients of the balanced chemical equation. What you're looking for, what you're trying to wind up with, which you've got over here on the X that you started with, that goes in the numerator of the mole-to-mole ratio. And then you're multiplying by the molar mass, so moles to grams, you multiply by the molar mass. Okay. Let's see, is there anything left, or have we done it all? That's all for you. All right, that's the end of that video, ladies and gentlemen. Thank you very much.